Hi, I'm Keith Stryer from Nvidia. I am delighted to welcome you to the World Smart City Expo. Nvidia is honored to participate. It has never been a more important time to talk about cities, and we commend South Korea for hosting this event. There's a global phenomenon across developed and developing economies. There's a great migration underway. 3 million people are moving to cities every single week. It is irrefutable that we are becoming an urban world. The trends are clear. The real question is whether cities are ready. 68% of the world will live in cities by 2050. The collective economies of the top 100 cities will make up 1/3 of the world's top GDP, and they will also generate 70% of the carbon impacting our Earth's atmosphere. The COVID pandemic accelerated the digitalization of government at every level, but perhaps also increased the backlog of construction projects and infrastructure upgrades. Cities also have new tools at their disposal, including artificial intelligence, but they do not always have the skills and infrastructure to fully capitalize on those tools. Of course, AI is not a singular technology. It is a constellation of different technologies and knowledge domains. It is also the most powerful technology force of our time. Now, cities can have the most ambitious AI plans, but without specialized infrastructure, the benefits to society do not materialize. There are 3 key points to understand here, right out of the gate. First, AI is not IT. So AI infrastructure is not the same as IT infrastructure. Enterprise software and the infrastructure that it runs on are both mature, whereas the infrastructure that makes AI possible is very specialized and still rapidly evolving. Second, this is not just about hardware. It's about specialized software, expertise, and ecosystems. Finally, cities need infrastructure that is resilient, and this requires a hybrid approach that combines local capacity and commercial cloud resources. We are now in the 4th industrial revolution. AI is changing the basis for private sector competition and public governance. To fully understand the new art of the possible, watch this video.
I am a creator. Blending art and technology. To immerse our senses. I am a healer, helping us take the next step and see what's possible.
Wow. Can you really sing?
Yes.
Oh, wow.
I am a pioneer, finding life-saving answers. And pushing the edge to the outer limits. I am a guardian, defending our oceans.
Roger that. Fly-by inbound.
And the magnificent creatures that call them home. I am a protector, helping the earth breathe easier. watching over it for generations to come. I am a storyteller, giving emotion to words and bringing them to life. I am even the composer of the music. I am AI, brought to life by Nvidia, deep learning, and brilliant minds everywhere.
The policy imperative to invest in AI is truly global. It extends to every nation and every city. Governments across the world started publishing AI plans in 2017. They focused on common themes like economic growth, research, transport systems and autonomous vehicles, startups and innovation, population health, and national security. Leading AI policy expert Jack Clark said it especially well. Machine learning is a uniquely omni-use technology that could impact almost every area of national policy. The next wave of public sector AI policy and investment is being driven by cities. Cities have been investing in digital and smart technologies for decades, of course, but advances in data science and computing are unlocking new frontiers of urban innovation. South Korea, India, Japan, Saudi Arabia, Egypt, and the United Arab Emirates are all examples of countries with national AI strategies focused on national goals and local AI strategies targeting more urban issues, such as improving the livability and sustainability of cities. Here are some examples of more traditional smart city projects across the world. At the top of the list is mobility and transport. Forecasting computer demand, for example, informs infrastructure investments, while automating systems like smart parking, bicycle sharing, plan ride sharing makes the entire public transit network more resilient. Sustainability and energy are also prime areas for AI. Forecasting and understanding energy system demand informs investments in grid modernization, as well as longer-term energy policies. Improving solar panel placement increases electricity generation and decarbonization. And there's crisis management. Early detection from citizen reports, posts on social media leads to faster response times. So does allocating and routing response resources using both AI and human judgment versus human judgment alone. Now let's consider how cities are taking AI to the next level. AI creates new ways to engage citizens and be more inclusive. Deploying conversational AI improves access to city services. Residents can get information by asking questions in their native language and in a natural way. This can be especially helpful for residents who are visually impaired. Now they can speak directly to government systems 24/7 using their voice to navigate. Housing is another complex area. Cities must make investments today that define neighborhoods and urban life for decades to come. Such decisions can be improved with deeper insights based on AI models that learn from data on housing and transportation patterns, economic activity, even weather. Lastly, we have urban planning. This is one of the most cutting-edge use cases for the future of cities. Now, when you think of a smart city, you think flying cars, 5G, and robots. Those are all part of the equation for sure. Mind-blowing projects like NEOM in Saudi Arabia, Woven City in Japan, and National Landing in Virginia are all good examples. Applying AI to improve land use regulations doesn't have the same high-tech appeal, but the potential impact is profound. Let's double-click briefly on this last topic. Traditional urban planning is time-consuming and laborious. Many factors need to be considered when generating the final planning scheme for a city. Researchers have been exploring how AI can be used to automatically generate urban planning solutions to improve this process. One team developed an AI model that generates land use configurations to help policymakers review the trade-offs of different approaches before approving them. Their AI model learned from data on urban geography, human mobility, and socioeconomic trends. The approach is not perfect. It has limitations, but it may someday transform how cities are structured and regulated. Let's step back for a moment and answer one fundamental question. Why are you hearing from Nvidia on the topic of smart cities? Nvidia, after all, is known as a semiconductor company and as a gaming company. Over the past 30 years, we have built on a legacy in chip design, on visual and scientific computing, gaming and simulation, to create the core technologies that drive the modern era of AI. Today, Nvidia is a full-stack accelerated computing platform. On top of our platform, gamers get lost in synthetic worlds. Developers build neural networks to solve complex problems. Scientists unlock new frontiers in biology, climate science, and space travel. Architects and engineers collaborate to design more livable public spaces. Nvidia is, in fact, the only AI company that operates inside all other AI companies and is uniquely positioned to partner with nations and cities to realize their ambitions. Governments are challenged to keep up with the pace of innovation in AI. Both the computational infrastructure and the field of data science are continuously evolving. Consider that the size of AI models are doubling every 3 to 4 months, requiring larger data sets and larger computers. This is exponentially faster than Moore's law. Now also consider where we're going. There are approximately 125 trillion synapses in the human cerebral cortex. Within 2 years, frontier AI models will exceed 100 trillion parameters, approximating the human cerebral cortex in size and complexity. This will enable computer vision and natural language models with incredible precision. They will still be considered narrow AI models, but they will also start to demonstrate some generalized knowledge capabilities and start a new chapter in automation. Looking forward, I see at least 2 significant trends on the horizons for cities. First, supercomputers are typically viewed as instruments for scientific discovery, only found in research institutes and government labs. But going forward, every city with an AI agenda will have an urban AI data center powered by its own supercomputer. Second, a new paradigm for designing cities is emerging. It is based on a hyper-realistic, physics-based simulation that will coexist with the physical world, and it's called the metaverse. Let's cover each one in more detail. Deploying AI at the scale of a city introduces a new level of complexity in data management and data governance. It also creates imperative to upgrade and expand the local computational infrastructure to accommodate the data collection, storage, and computing requirements of a smart city. The optimal approach will be a hybrid one. This combines an urban AI data center with an on-prem AI supercomputer that can train and deploy AI models for rapid local adoption. This capacity should be connected to the commercial cloud to leverage their scalable services and innovation from the cloud to the edge. Computing capacity will emerge across the city, embedded in smaller form factors inside devices, sensors, and machines. Cities have many edges: phones, cars, street lamps, buildings, bicycles, bridges. These are all the edges of a city. Ultimately, the urban AI data center will be the digital heart of smart cities. One of the most powerful new workloads that can run on top of an urban AI data center will be the new generation of digital twins. One of the earliest examples of a working digital twin was in 1996, the construction of the Heathrow Express facilities in London. The business case for digital twins is very simple. If you can test, predict, and solve on virtual representations of an object rather than testing on the physical object before it's engineered and built, you can save time and resources transforming the entire design and innovation process. What if we can apply this concept to a city? What if you can create a virtual world governed by the natural laws of physics? This is the metaverse, and Nvidia built the foundation to deliver it. We call it Nvidia Omniverse. More than a visualization, this enables a simulation that fully characterizes the behavior and interaction of physical objects as if in the real world. Check out this brief video. With this platform, mayors, city planners, architects, engineers, and builders can work together to design public spaces. They can simulate how those spaces will feel and react to other elements in the environment. Then they can use that simulation as a digital twin, coexisting with the physical world to support ongoing analytics, governance, and operations of the city. Before the first brick is set, cities will have the ability to accurately model every beam of light through the windows of a new building. See how the texture of carpet looks against the sheen of new wallpaper. See the impact of rain and wind on roof tiles. Assess the impact of sound from outside traffic on a new school. A physics-based metaverse is a game changer for cities. It also sets the stage for some novel possibilities. What if you can not only design spaces, but also the machines that will operate in them? What if you can safely train robots to be robots inside this simulation before they are launched into a factory, a hospital wing, or onto your city streets? Nvidia has already put this idea into action. Meet Carter, a robot we built to deliver meals. We created a digital twin of Carter and a simulation of our Santa Clara headquarters. Carter learned how to be Carter inside this simulation. He ran into walls and people, and he got lost in the hallways. But eventually, Carter figured out the right way to get his job done. Then we downloaded that experience, that AI model, from the virtual world into the real one. Now watch this video with side-by-side views of Carter learning inside the simulation and executing his task in the real world. Smart cities will be pulsing with purpose-built machines, operating autonomously in different functions, from cleaning sidewalks and delivering mail to monitoring for health hazards and inspecting bridges. Nvidia's technology creates the opportunity to accurately model infrastructure, landscapes, weather, creating the synthetic basis for training machines to safely coexist with people. This same technology platform is being adopted by many of the world's leading auto companies to train autonomous vehicles, allowing them to learn how to drive safely inside a virtual world before they hit your streets. Cities may also want to leverage this same technology to test and certify autonomous machines in a virtual simulation of their city before granting them approval to operate in the real one. My closing point is about the future of smart cities in South Korea. South Korea is a leading digital nation, widely recognized for the strength of its domestic semiconductor, auto, and electronic sectors. government initiatives that prioritize emerging technologies like AI and 5G, and a powerful political commitment to innovation with the new digital deal. South Korea also has a track record of successful smart city projects like Busan. I expect your nation will continue its legacy of leading in the implementation of AI across all industries, government, and especially cities. Well, that's it for now. I hope you enjoyed the keynote. It was an honor to participate in your event. On behalf of NVIDIA, thank you and be well.